Hello everyone, today I want to solve the issue, the robots in a grid. And in this problem, the robot need to travel from the top left to and arrive to the destination of the button right. And in this problem, we will use the recursion solutions, which is the depth first searching. And in this question, we will get a map. In the zero symbol, the path which we can walk, and the one or minus one represent obstacles. And robot have a two action can take. The first action is walk downward, and the second action is walk rightward. And if we bump with the obstacle or touch the boundary, it will go to the previous steps and then try to take the second actions. So for example, the robot is moving downward, and then it touch the boundary and it will try to take the second actions and rightward, and until it touch the destination. Okay, to solve this problem, we first need to give the to get the length of the map. So in this situation, I will first make two variable m and n to store the length of the obstacles, and the obstacles row length will be stored at m, and the obstacle grid column length will be stored in n. And when the robot is travel, we want to visualize the traveling trajectory. So I use the answer empty list to store. And just push into this function. And then if the robot cannot can find a solution, we will return the trajectory and also tell the user, yes, that is a path. And if the robot cannot find any path, it will just return the empty array list and also the node. And what is the condition? We will call our depth first searching function. Here I will further define a depth first search function and put the current position I and j. Things we start from the top left, so the position of the top left is 0, 0. So we can put our DFS function 0, 0 here. And when you go inside to recursions list the function, we have to first make sure the input position is not out of boundary or standing on the obstacles. If I is bigger than the length of the row, or the j is bigger than the length of the column, or the robot is just standing on the obstacles, then we can say this is impossible to find a path. So we can return the false to the user. And when robot is traveling, we don't want to is just when you bound to the boundary, we should go back to the previous position and then take the second actions. And so we don't want the robot just fall into the infinite loops. So we recall our map. How to recall the map? We can simply change the map to the -1, which means we make the visit position as the obstacles. By this way, robot will not keep repeatedly visit the position, visiting the already visit positions. By this way, it will not fail into the infinite loops. And besides, since we want to visualize our path, so we should store the path. By this way, I will use NS list to push to append the current position. Okay. So this if else is the boundary condition. And then the most important part is the recursion, the DFS. So we have to check when we move the DFS, is it in the destination? If it is in the destination, we can return true. And the destination is the end of the row and also the end of the current. So in this condition, we will return true. Besides, we want the robots recursively to search downward and right. So there is two actions. The first action, we let the robot move downward. The second action is let the robot move rightward. And if the robot is not in the destination or cannot move downward and rightward, that means this current position is impossible. So we should return false, because it's impossible to find a possible trajectory to connecting the top left to the bottom right. And also we want to move back to the previous position, so we pop the trajectory which we stole before. So by this way, we get the answer. The robot move on the top right 0, 0, and then move right 0, 1, and then go downward 1, 1, and then 2, 1, okay, 3, 1, and then 3, 2, and then 3, 3, and then first action 4, 3, and you touch a boundary, so you will choose the second action 4, 4. And you can see there is a wall -1 between the start point and the destination. So there is not possible to have a solution. So that's why we return 0. Thank you very much for your listening.